So in this video, I want to do some problems dealing with significant figures, and specifically, I want to talk about when 0 is significant or not. The first rule you usually see on any list is something like all non-zero numbers are significant. So if I apply that to this number here, then yes, the 2 and the 6 are significant. 0 is the number that's going to give you the most difficulty. Now this problem set that I have here, I just pulled offline. And basically, it runs through all the strange little rules that you have to deal with 0. By the way, you should watch the lecture video dealing with significant figures really before watching this video here. Because again, I'm just going to focus on 0. So one of the rules for significant figures states that if the 0 is in between two non-zero numbers, then it is significant. So the answer to this one is 3 significant figures. Now, if we take that same number, here number 2, and we add a 0 on the right hand side, well, so the same rules apply to those 3 numbers, right? They are all significant. So notice what I'm doing. If I'm underlining the number, then it's going to be significant. Now this new 0, it's not in between two non-zero numbers, so you can't use that rule. What you have to realize here is that the 0 is on the right hand side and a decimal is shown. When you have that particular combination, then that 0 is significant. So in this case, there's 4 significant figures. Briefly, when a student learns significant figures, oftentimes it is just a list of rules that you apply to a number. But ultimately, what it is doing is it's trying to account for the accuracy of the number. Like for example, in these two problems here, if we imagine like both of them to be in degrees Celsius, let's just pretend that the same unit is present. As I start adding numbers on the right-hand side of the measurement, well, really what that tells me is that I have a more accurate number, that I know with less uncertainty, more certainty what the actual temperature or distance or whatever you're measuring is for that measurement. So 3 significant figures versus 4 significant figures, especially if it's extending into the decimal range, means that the greater significant figures indicates greater accuracy in that measurement. And I go into a little bit more of that in the lecture videos. Now again, this video is just trying to get across how to deal with 0. Okay, so notice there's a slight variation on this 206 theme. Okay, so we know those 3 are significant. Now in this new number, we have zeros on the left-hand side. Well, as it turns out, these are never significant. So there's only 3 sig figs here. Oftentimes these are referred to as placeholders. The way I think about it is that if you have these zeros just strung out on the left-hand side, it's really telling you how far you have to go down before you actually find real information. Think of it that way. Real information, more accurate information is significant to our measurements. Now this one is a combination of zeros on the left and the right. Okay, we still have our 206. That's great. Again, like I said, these are zeros on the left-hand side are never significant. And then the phrase that I used for this problem, I said, if you have a 0 on the far right-hand side and a decimal shown, it is significant. Well, that's what we have here. We have these zeros, they are on the far right-hand side, and the decimal is showing. So what we have here is actually 5 significant figures. Just to expand on that a little bit, if I had a whole string of zeros on the right-hand side and a decimal showing, all of those zeros would be significant because I'm using some kind of instrument, some kind of device that has a high degree of certainty. It'd be like an expensive instrument that can measure something very accurately. Now, you can use all the regular rules for sig figs if you want to when you come across something like this with scientific notation. But the bottom line is, if you see something in scientific notation, then that means all of those numbers are significant. That is one of the reasons why you see scientific notation in science so often. Because you don't have to remember a bunch of rules. You just say, okay, how many numbers are there? That's the number of significant figures. So this is 4. And notice, you still have your core 206, right? 0 on the right-hand side with decimal shown, therefore significant. Okay, again, you can apply the rules if you want to. And then just briefly, what does this 10 to the minus 3 mean? So just to be clear, when you say, you can imagine this as a mathematical problem if you want to. that number times 10 raised to the minus 3. Well, what's going to happen is basically it's going to push the decimal 1, 2, 3 positions to the left. You make it a smaller number. The minus on the exponent makes it a smaller number. So that'd be 2 zeros here. And we'd want to include that 0. Okay, we have our same 206. Yes, we know that's significant. All right, zeros on the right-hand side, but notice no decimal is shown. That decimal is a big deal, okay? If no decimal, then those zeros are not significant. So this one only has 3 significant figures. And let's just, say a few things. If I was to take this number and convert it into scientific notation, there's no decimal shown there, but it's implied that it's at that position. 3, 4. So when I'm converting a normal looking number into scientific notation, I move that decimal until it's just to the right-hand side of the first non-zero number. So it's going to be 2, 0, 2, or 0, 6. And again, right, we've already established those zeros are not significant, so we're going to drop those from the expression. How many decimals did I move? 1, 2, 3, 4. How many places did I move? 4. And one way to keep track, if this is a big number, then this is a positive exponent. Again, the scientific notation it's really like a mathematical formula. 2 times 0.06 multiplied, or I should say 2.06 multiplied by 10 raised to the 4 will give you that number. Now also with significant figures, there's the application of them with addition, subtraction, multiplication, and division. And again, please watch the lecture videos on those topics, I think, before doing this, watching this video. So I've already performed the math. That's really not the point, you're just plugging this in your calculator. The point here is trying to establish, what's the final answer. When it's addition or subtraction, it's not the greatest number of significant figures that you're looking at. It's actually the decimal place that you're looking at. So this one is at the 3rd decimal place, or the thousandths position, hundredths position, 10th position. In the context of accuracy for these values, that's a very highly accurate number. That is a less accurate number because there's fewer decimal places there. Your final answer needs to reflect the accuracy of your least accurate number. And that is determined, in this case, by the number of decimal places. So what I want to do here is I want to round off to the 10th position because of the 2.5. Now the rounding rules state that if the next digit down is 5 or greater, we're going to round this digit up. So the answer is going to be 3.1. And there it is. Subtraction, it's a similar game. It's a number of decimal places or places for the the last significant figure. Well, if I analyze the significant figures for these two numbers, that 6 is significant, but that 0 is not significant. So this one is significant to the 10's position. This one's to the 1's position. This one is least accurate. Therefore, I want to round off at that position. And so, again, this is 5 or greater, so I'm going to round this one up here. 210, that's fine to leave it in that notation. Oftentimes in science, what we'll do is actually, if there's a 0 floating there that's not significant, we will go ahead and convert that to scientific notation. That's a very common technique that you see. But honestly, either one of these is correct. Now we're looking at multiplication. The rules for multiplication and division are different. The rule here is that you're actually counting up the total number of significant figures in each number that you're multiplying. There's 3 there, there's 1 there, there's 2 there. And then the fewest number of sig figs is going to dictate how you round off your answer. So you want to keep the first significant figure here. So what is that? And this is accurately done, okay? 0.02 times 50, that's equal to 1 times that is 11.1, okay? But if I want to round this just to the 10th position, well, what's the rule? Okay, well, I want to round that position. That position there is 4 or less, so that means that I just sort of drop everything. I just put a 0 there. So the answer is actually 10. Where again, that 1 is the only significant figure in that number. We often place it in scientific notation, and in this case, it would be 10 raised to the 1 because I was just moving one time. I'd be moving the decimal one place. So there's the answer. By the way, notice what happens to the units. They all come together. So this is like a volume calculation. You know, centimeters in one dimensional, right? It's just a length. Length cubed, that's like a volume. And you see that expressed in the exponent in the centimeters. And then finally, if we do this division problem, you actually get this repeating pattern of 2475 all the way down. And remember, multiplication division, you go in, you say, well, how many sig figs do I have in this number? How many sig figs do I have in that number? And then I say, well, I got 3 sig figs there. I have 4 sig figs there. Therefore, the fewest number of sig figs is going to dictate how I round off that number. I need 3, so I'll pick the first 3 that I come to. I'll look at the next digit down to decide how I'm going to round off. And notice, I don't care about all those other ones. It's just that one. 5 or greater, I'm going to round this guy up. So this is 5.25 is the final answer. And that is going to be on, there it is. Okay. So just, again, this video was really specific about how to deal with 0 more than anything else. Hope that helped. Thanks.